Welcome back to the class on electrical vehicles and hybrid electrical vehicles. In this lecture, we are going to discuss about the sizing of battery for the EVs. Sizing is nothing but a design. What is the rating of battery pack we have to use in an EV for a given drive range? That we are going to see in this class. There are four different parameters we have to consider before going to select the battery in EVs. The first one is the chemistry of the battery. Nothing but what type of battery we are using or we are selecting for the EV. Next, voltage or the volt amperes. Nothing but a capacity of a battery. Third one is the average energy consumption of a vehicle on a drive cycle. Fourth one is the vehicle range. Nothing but for how much range of speed we are designing the EV. We know that battery cell is consisting of 5 major parts. One is the electrodes. Whenever you are talking the electrodes, it has a anode as well as cathode. Both anode and cathode are separated by the separator, terminals, electrolyte, enclosure. Practically, we are using three types of batteries. One is the cylindrical battery, another one is the prismatic battery. In case of cylindrical battery, hard case, nothing but the outer surface of the battery is hard. In case of prismatic battery, hard case as well as a pouch type. But in case of pouch type battery, surface of battery is not that much of hard. Generally, in case of EV, we are using the hard case and pouch type batteries. We know the different types of batteries are available commercially, but out of all these batteries, we are using only the lithium ion battery. If we compare the different types of batteries, on the x-axis we have taken the specific energy, on the y-axis we have taken the specific power. This is lead battery, this is nickel cadmium battery, this is the nickel manganese hydride battery. So in this manner different batteries are there. This is zebra battery. Out of all these batteries, lithium ion battery has a high specific power as well as a high specific energy. This is the reason that we are using a lithium ion battery in a electrical vehicles. Battery pack. Suppose if you see commercially, we have a battery cell. The battery cell is giving maximum 2 volts or 3 volts or 4 volts. But when you're going to use the battery pack in a EVs, it requires a 400 volts or 800 volts. So to meet that much of voltage, you have to connect these cells in a series to increase the voltage. So this is nothing but a string, battery string. Now to increase the current capacity of the battery pack, you have to connect this type of strings in a parallel to meet the how much power is required for the EVs. So this is nothing but a battery pack. Now here we are comparing the sum of the batteries in terms of energy density. These are the different types of manufacturers: Panasonic, A123 system, Molicel, A123 system, Toshiba, Hokham. The type of battery is the cylindrical, pouch type, pouch type, pouch type. Model number of the battery, this one. Energy density of the battery is 11.52, 8.25, 9.62, etc. so on. Energy density for volume. For a cell, it has some amount of volume as well as it has some amount of energy. That energy divided by the volume, that gives the energy density per volume. That we denoted by I. Next, energy density per weight. So every cell has a some amount of energy as well as weight also. That energy divided by the weight, that gives the energy density per weight. These two parameters are very important when you're going to use that battery pack in a EVs. Average energy consumption. So how we are going to find out the average energy consumption is, this is the worldwide harmonized light vehicle test procedure. If we observe this graph, on the x-axis we have taken the time, on the y-axis we have taken the speed. This range of speed we have taken as low, this range of speed we have taken as medium, this range of speed we have taken as a high, this range of speed we have taken as a extra high speed. This is the one standard speed cycle. This is also we are calling as a WLTP drive cycle. Now to find the average energy consumption, take one vehicle. Now you drive that vehicle to follow this speed cycle. Then you have to measure how much energy is consumed by the vehicle. Now the total energy is consumed and how much distance is traveled. So the total energy consumed by the vehicle which is following this drive cycle divided by the total distance, that gives the average energy consumption. The average energy consumption of a propulsion system EP is, we have taken here, 137.8 watts per kilometer, because we have taken the 1 ton vehicle which is followed this drive cycle for the 250 kilometers. So we got this value. Next, now we want to design the electric vehicle for how much speed range. Generally we have taken the speed range is the 250. So the 250 into that average power consumption, that gives the total energy which is required at a vehicle which we are going to design. That is the energy which is available at the wheel. But how much energy should be given by the battery? Between the battery and energy available at the wheel, there is some amount of energy or power will be wasted in a motor as well as transmission. So how we are going to find out that value means, EB is nothing but a total energy which is available at a wheel. When the vehicle is going, there is some amount of energy also will be wasted for the ACs, audio system and auxiliary components. That energy also we have to measure it. See, in this case we have got the auxiliary energy, that is 9.241. So how much energy is required to move the wheels on the road, and auxiliary energy, so we are adding this 2 into 2 minus eta p. This eta p is nothing but a efficiency of a motor as well as a transmission system. Generally this eta p value will be 90%. If we substitute those values, we nearly are getting the 161.77451 watt hour per kilometer. This is a Tesla model battery. It is consisting of 74 cells in a parallel group, 6 groups in a series for a module, 16 modules are in series. So total 7104 cells in total of a battery pack. How much voltage it is giving means 350 volts it is giving. Now come back to the what is the energy which is available at a battery. Now once we know the value of how much energy should be given by the battery pack, then we have to find out the, so in this manner we have to find out this much of power which should be given by the battery pack. So the average energy into distance, that gives the this much of energy should be given by the battery. Next, how many cells you have to keep in a series? Suppose if you are designing the battery pack for the 400 volts, we selected a one cell such a way that it is giving a voltage of 4 volts. So 400 by 4, nothing but a 100 cells you have to keep in a series. Next, energy content of the one string. In one string, in this example, we kept the 100 cells in a series. We know the how much energy stored in each cell. So the amount of energy stored in a string equal to the number of cells in a string into energy content of the each cell, that gives the total energy content of a one string. Already we know the value of how much energy is given by this battery pack. Now we have to divide this value divided by the energy content of the one string, that gives the how many strings we have to keep in a parallel. Now the total number of cells in a battery pack, that is equal to the number of parallel strings into number of cells in a series, that gives the total number of cells in a battery pack. Next we are going to find out the battery pack mass. So how we are going to find out the battery pack mass means, we know the mass of each cell, that we have to multiply with a total number of cells, that gives the total mass of a battery pack. Next, volume of the battery pack. Once we decided to take one battery cell which we are going to keep in a battery pack, means we know the value of volume of the cell also. So the volume of the cell into total number of cells in a battery pack, that gives the total volume of the battery pack. Now we know the total mass of a battery pack as well as total volume of the battery. Now we can easily find out the specific energy for unit volume as well as specific energy for unit weight. So based upon all these values, we are going to decide what is the battery pack we have to use in a electric vehicle for getting the specific amount of the drive range. Thank you very much. If you have any doubt, you can ask me directly or you can ask in the comment box of my YouTube channel so that I am always welcome to answer all your questions.